All right, so we talked about practical limitations of the real life, like non-ideal op amp, previously in this section of the module 5. We talked about how if there is some, less than infinite input resistance, then we're going to end up with some voltage difference across these rather than actual zero voltage between them, where they're actually equal, which is okay, assuming that that difference is relatively small. Because if it's very small, like it was in our example, like in the microvolts, then we don't care. We can neglect that and assume that it's zero. We also talked about how there might be some output resistance. And if there's output resistance, then some of our output voltage that we want is going to get dropped across this output resistance rather than showing up at our output that we actually see. So we talked about some of those limitations. And what we didn't talk about yet is the power supply limitation. So an op amp is what's called an active circuit. It's an active circuit. Okay. And most of the elements that we learned about in this class, like resistors, inductors, and capacitors, these are called passive components. And the reason they're called passives is because they don't require power in order to behave the way that they're supposed to behave. So if you if you put a voltage across a resistor, it's going to have a current through it according to Ohm's law. It doesn't need an additional power source to do that. It basically just behaves that way naturally. The same goes for inductors and capacitors. You don't need to power the device itself in order for its IV characteristics to somehow appear. If I pass a signal through a capacitor, an inductor, or a resistor, I'm not powering the component itself. I'm supplying power, sure, as an input, but I don't need to apply power and an input, if that makes sense. Like for the op amp, I'm applying an input, but what I have neglected to mention this entire time is what's happening, because we haven't even drawn it that way. We've basically been drawing an op amp as a 3-terminal device, right? We have our plus input, our minus input, and our output, but we haven't drawn the positive supply and the negative supply rails, which is what I'm showing here. I have a positive supply rail and I have a negative supply rail. And what those rails basically are, it's the power that I'm actually supplying to the op amp circuit. So remember way back, let me go back to that slide actually real quick, just so you can see it. Way back in this slide here, where I showed this circuit. In this circuit, I'm applying, I'm obviously going to apply an input, VM and VP, right? Those are my two inputs to my op amp circuit. But I also need this little T right here, all these T's that you see, these represent another power supply that I need to use to power my circuit. And then all these grounds are basically the minus supply that I'm using, right? So if I were to come into this circuit right here and draw, or even this one, and draw the power supply rails, in this circuit, it's this little T at the plus rail, which symbolizes some voltage. It might be plus 5 volts, it might be plus 9 volts, it might be plus 2 volts, and then my negative rail is ground. So what this tells me is that any inputs that I put in here, doesn't really matter what they are, it doesn't matter what the gain is, I will never be able to get an output voltage that is outside of these rails, okay? We call them rails because if I'm looking at my output voltage as a function of time, I basically have a 5-volt, what you could call rail here, and a 0-volt rail here, and my outputs will only ever be inside of these rails, okay? They cannot, so I can't basically put an input of 2 volts in with a gain of 10 and expect to get 20 volts out, because it just can't happen. My power supply rails are limiting that from happening. I'm only supplying 5 volts to the op amp itself. The internal circuitry of the op amp requires a power supply, which is these T's that you see in this circuit. Okay, so let's go back to that slide now that we're on. Let's get back there. It is here. And so you can see that in the op amp, right, they're telling me here, oh, I'm going to supply a plus VCC to this top. Basically, that would be my positive supply rail, and then this bottom one is my negative supply rail because, you know, from 0, this rail is at VCC. If I go across this one, I'm at minus VCC. So I'm powering this op amp, and my rails, if I were looking at this with respect to time, I'd have a rail at plus VCC and a rail at minus VCC, and they're saying that I will not be able to get an output that is outside of these rails. My outputs will have to be somewhere in this region between negative VCC and positive VCC. So if VCC was 5 volts, then this would be plus 5 volts and minus 5 volts. I would not be able to get an output that's outside of those rails, okay? That's a very important practical limitation, because when I first learned op amps, and I learned that all you had to do, for example, for, let's say, a non-inverting amplifier, right, where I have my input signal on the plus terminal, and then my minus terminal, I've got my feedback. I'm sitting here thinking, oh my gosh, so V out is equal to V in times 1 plus RF over R1. So if I just make RF over R1 huge, for example, let's say I make it 100K over 1K for this term right here, then I get V out is equal to V in times 101. And I'm like, oh my gosh, that's so exciting. So if I need to get a huge voltage at my output, this must be how they generate high voltage. Well, that's not true. If I put an input voltage of 1 volt and I multiply it by 101, then this is saying that my output should be 101 volts, which is awesome. But if my power supply rails are only plus and minus 5 volts, all my output is going to do, it's going to try to go up to 101, and it's going to hit the 5 volt rail, and it's just going to stay right there. It won't go any higher than 5. I would need to supply more than 101 volts if I wanted my op amp to actually be able to get to this level of output voltage, okay? So hopefully that all makes sense. If you have questions, obviously feel free to ask, but it's just, the point is that you are limited at the output directly by your power supply rails. And so in any practical op amp, you need to supply a positive voltage here and a negative or a 0 voltage here. This could be negative or it could be 0. And those power supplies set what your outputs can be at a maximum and a minimum, okay? So we're gonna go ahead and stop here. We have finished op amps. I am completely done with op amps, and now I'm going to enter the last section of this class, which is talking about circuits in practice. I'm going to talk about components, circuit boards, integrated circuits, all the practical things in the real world of circuits, how they're designed and how they're manufactured. And I think it's going to be really exciting, really practical information that I think is really valuable for students at your level. I didn't learn this stuff till much later, so I think it's really exciting that we're going to get an opportunity to talk about that stuff as we wrap up EE 220. Okay, going to end this video here.